point, it's again a very important. Sometimes we say omro. Omro का मतलब होता है rainfall in Greek. Omro means rainfall. Okay? And the second thing you can say minero. So minero means you can say that rivers or you can say streams. Rivers or streams. Suppose just add ombro plus trophication. That means they are getting their nutrients through rainfall. Minerotrophication means they are getting their nutrients through the rivers. And now tell me among these which one is the most rich in nutrients and which receives more nutrients? Minerotrophication, right? And just you need to know here, and those those wetlands which receive their nutrients through what? Streams and rivers can be called as fens. So these are the wetlands. So which receive their nutrients only through what? Rainfall. Okay, and for them we can say bogs. Box means is all over the year water is okay, this is a waterlogged condition indeed, or water is present, whatever you can say. Clear? Fens, bogs, swamps, and one more is swamps and marshes. So these are the 4 types of wetlands. Okay, we learn in environment, nothing to worry. Clear, right? Clear, right? And what do you mean by eutrophication? And so which protocol is there to reduce the impacts of eutrophication? Which protocol we have at the global level to reduce eutrophication? Gothenburg. So Gothenburg protocol. It is of year 1999 में आया था. Clear हागिद्रे? And here this is all about what? O3 climatology. O3, and that is we are discussing in stratosphere. And if they ask you to write about the stratosphere, and you need to write all this. समझ में आया? And we have good and bad ozone concept, and the good ozone has to be protected, and it is done indeed through the Vienna, Montreal, and one more is Kigali. Isn't it? And these 3 are very important in case of the bad ozone is concerned, and we have Gothenburg protocol, and our duty is to reduce the bad ozone emission, right? And this is actually we have done in Gothenburg protocols framework. I hope you have understood this. Clear? And after that what we have? Meso. Meso in the sense, as I told you, just to say, yes, look, as I told you, up to here the source of the heat is surface or terrestrial radiation, and from here it is directly heated by sun, isn't it? And okay, and this layer, okay, is in between these two, isn't it? That's why it is called in between layer or mesosphere. Getting my point? And you can write as it is mesosphere. You can write as mesosphere, and it can be called as stratophos because temperature again becomes constant over there. Okay, this is a phos, mesosphere. Okay, mesosphere. Yeah, ionosphere, then thermosphere, then exosphere. The thermosphere में ही ionosphere है, ठीक है? Yeah, but there is no proper ionosphere, but we say, okay, ionosphere. देखो, and it is also called as homosphere, and it is called as heterosphere. Fine? Homosphere and heterosphere. A hetero means atomized or different, not same. we have different atomized molecules. Ayatra Mailiurgo, understood? Yes, clear, right? So ionosphere, right? As name itself indicates, it is zone of ions. Zone of ions. Ions means charged. Okay, zone of ions you can say. And now if I say these ions are the charged particles, they are very, very important here. To what? To reflect the waves or radio waves indeed. Okay, now tell me, the reflection will be more when there will be higher or high density electrons. Our density of the electron should be relatively more. कितना ज़्यादा होगा उतना okay reflect होता है. And suppose if I want to say, okay, just you can say this much, okay, it is the ionosphere. I'm just writing here is A, B, C, D. Relatively tell me and where you can find highest reflection or density of the electrons. D, right? Because somewhat it is relatively near to the sun and that means it is getting more ions. Getting my point? Therefore, if I say, look here, D, what we have? C. Okay, fine. Hagbeda, we can write it as A, B, C, D, whatever you can say. समझ में आ रहा है ना? Right? And suppose if I want to say here, okay, ED means Enforcement Directorate. ED means AD. Yeah. ED means what ಹಿಡಿಬೇಕು? ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ. ಸುಮ್ಮನೆ ಇಲ್ಲಿ ಇದ್ದೀರಿ ಆದರೆ ಯಾರೂ ಇಲ್ಲಿಲ್ಲ. ಓಕೆ, electron density. Okay, relatively where you can find? Yes. Can I write like this? देखो इसको A को ओके हम टेक्निकली हम D बोलते हैं, C को E बोलते हैं, ओके इसको F बोलते हैं, इसको G बोलते हैं. समझ में आ रहा है? D E F G समझ में आ रहा है? F को फिर हमने F1 और F2 मानते हैं. Okay, now tell me which layer reflects more? D and E? E. E, right? E था ना? E. And after F or F1. Next F2. Next G. Like this. बस इतना ही याद रखो. Yeah. ಬರ್ಕೊಂಡ್ರ ಡಿಫ್ರೆಂಟ್ ಲೇಯರ್ಸ್ ಆಫ್ ಅಯೋನೋಸ್ಫಿಯರ್ ಯಾವ್ದಾವ್ದಿದೆ ಹಾಗಿದ್ರೆ ಡಿ ಲೇಯರ್, ಎಸ್ ವಿ ಹ್ಯಾವ್ ಇ ಲೇಯರ್, ವಿ ಹ್ಯಾವ್ F1 ಲೇಯರ್, ವಿ ಹ್ಯಾವ್ F2 ಲೇಯರ್, ವಿ ಹ್ಯಾವ್ G ಲೇಯರ್. ನೋ, ದೇ ಆರ್ ಆ್ಯಕ್ಚುಲಿ ಗಿವನ್ ಇನ್ ದಿಸ್ ವೇ. ಡಿ ಇ some scientist actually, not me, okay? Yeah. Who is given D, E, F, G means it's not by Manju sir, it's given by some scientist. समझ में आ रहा है आकर्ष? Yeah. इल्लिवರೆಗೂ ಹಾಗಿದ್ರೆ. And after that we have the thermo and exo. Exo means we can say directly it is outer layer or last layer we can say, right? And this much only you need to know. And the mesosphere is where the meteorites hit and the shooting star usually occur. Okay? And in the ionosphere we can find what? Auroras. That's we have discussed now. Aurora borealis, aurora australis and those things, okay, usually occur there. समझ में आया? Right now देखो हमने क्या क्या बात किया इधर टेम्परेचर में. देखो we discussed heat budget, clear? The second is lapse rates, stable and unstable zones. ये तो ऑलरेडी आपको पता है, टेम्परेट, ट्रॉपिकल एंड दोज थिंग्स. एंड नेक्स्ट व्हाट वी हैव डिस्कस्ड? लेयर्स में टू टाइप्स नॉर्मली, होमोस्फीयर, हेटेरोस्फीयर. इन होमोस्फीयर वी हैव Two types, major and minor layers. Major layer is troposphere, stratosphere, mesosphere. Minor layers are tropopause. What do you say that? Stratopause, then mesophause. समझ में आ रहा है ना ಬರ್ಕೋಬೇಕಾದ್ರೆ ಎಲ್ಲಾದರೂ ಒಂದು ಕಡೆ ಬರ್ಕೊಂಡಿರಿ ನೆನಪುಳಿಯುತ್ತೆ ಓಕೆ ಓಕೆ ಹೋಮೋಸ್ಪಿಯರ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಕ್ಲಾಸಿಫೈಡ್ ಆಸ್ ಹೇಗೆ ಹೋಮೋಸ್ಪಿಯರ್ ಹೆಂಗೆ ಮೇಜರ್ ಆ್ಯಂಡ್ ಮೈನರ್ ಬರ್ಕೊಳ್ಳಿಮ್ಮ ಮೇಜರ್ ಆ್ಯಂಡ್ ಮೈನರ್ ಲೇಯರ್ಸ್ ಮೇಜರ್ ದೊಡ್ಡ ದೊಡ್ಡವು ಯಾವುದ್ಯಾವುದಿದೆ ಅದು ಎಸ್ ಟ್ರೋಪೋಸ್ಪಿಯರ್ stratosphere, yes, mesosphere. Minus yavudappa tropopause, stratopause, mesophause, no phause. Only three, okay? Only three. Yeah, phause means? Constant. No. Sir is giving us different answer. Yes, sir. Phause means? No. Okay. Yeah, badiyodu. Yeah. Aita. And now, one thing you need to add here is the factors affecting distribution of temperature. So, okay, next one, which one it is? Sixth one, right? Sixth one you can write as factors affecting distribution of temperature. Okay, distribution of temperature. Distribution of temperatures. Which one it is? Fifth, right? Now tell me what are all the factors affect the distribution of temperature? Okay, directly I can say it can be explained. The first thing I will write as okay, Milankovitch circulation, or else technique you can say. It affects, right, precision, obliquity and eccentricity, right? And a second thing, can I write latitudes? Latitudes differs or the temperature distribution variation agattalva. How you can say higher latitudes are less temperature, lower latitudes are, yes, that's it. And a second you can say altitudes. Next factors you can say here is altitudes. Okay, you knew this. How? Okay, as you go up, temperature decreases. Because of the example you can say, or it can be explained through ELR and ALR, right? Okay, ELR and ALR can be. And the fourth one you can say, tell me, and what else again? Can I say, okay, fine, look, before that, something you had to know here. So what it is, we don't know. What it is, we don't know. But I knew, but you people don't know. Okay, it is A. A means your brothers and sisters, where they live? Your brothers and sisters, where they live? Africa. Okay, Africa. Okay, it's our homeland. Okay, and if you want to experience how you were in 1990s or 1980s, you have to visit Africa to experience that. And how you are now, and the same will be them after 20 to 30 years or even 50 years. Yes. So, what all the factors do affect the distribution of temperature? That's one is Milankovitch, then latitudes and altitudes, and now we are discussing it is Africa. Okay. And now we can write it is South America. What it is? South America. Okay. And just to say, it is what? It is water and it's the Atlantic Ocean. What it is? Yes. Did you see Atlantic Ocean? Yes. When? Now itself. No other. Okay, Atlantic Ocean. Right? And just assume, and if the wind is acting or blowing in this direction, so what happens? And it can push this water towards this side? Yes. It's possible, right? Yes, it can easily pushes the water towards this side, and that means this, okay, the stagnated water now gets the motion, right, and it start to move, right. Anything in motion can be called as what we called current, isn't it? Anything in motion can be called as current, and here what is in motion? The huge mass of water of ocean. That's why it is called as oceanic current. What we can call as oceanic current, right? Right. Yeah. No. It's not always horizontal. It can be a current means both. Okay, possible. And now tell me, suppose if I take one bottle of water and if I hit this dash, okay, now tell me the water will come my side, right? Right, and if I take a barrel of water and if I blow, or if I hit this, and what happens? It will go away from, right? And same context, and just assume here, okay, the intensity of this water compared to this this continent, and whose resistance force is relatively more? Continent. Therefore, this can push this water like this. समझ में आ रहा है? And after certain level, and it will go, and you must know one more thing here is, right? Okay, some basics you need to know, and so that basics mein you can write it as note. So note mein you can write, this is the first one I am writing, and the second one you must know here. Look, if you rotate something, what you experience some wind. Or else that wind is producing what? Some energy, right? And that energy, or the force can be called as Coriolis force. What we can call it as? Coriolis force. And the Coriolis force is nothing but it's directly linked with rotation of Earth. Getting my point? It is directly linked with rotation of Earth, I can say. Getting my point? Yeah. And you have to say, so because of, as I already told you, okay, centripetal force is more at, centripetal force of Earth is more at equator, and again the centrifugal force is also more, right, action and reaction. So therefore, the Coriolis force is relatively zero at equator, and it increases as you go, moves pole side or poleward. Getting my point? And you can write here is max. Max means max, not Sudip max, it is maximum. And you can say here is 0. Okay, and that means it is what? Actually it is increasing, isn't it? And if you are going like this, means it is increasing. Okay, increasing, that's you can say. Early. So समझ में आ रहा है Coriolis force, right? Because of that, ನೋಡಿ ಹಾಗಿದ್ರೆ, okay, the bend is maximum. Okay, now you can one more thing. So bending ಏನಿರುತ್ತಲ್ವಾ, it is directly linked with Coriolis force. Now means higher the Coriolis force, higher would be the bending. So bend ಆಗ್ತಕ್ಕಂಥದ್ದು, ಅದರ push ಮಾಡ್ತಕ್ಕಂಥದ್ದು. And now, so because of, okay, ನಮಗೆ ಗೊತ್ತಾಯ್ತಿದ್ದು, because of it is window. Okay, it is also, okay, because of resistance force of continent aita, and after reaching some height again it will deflect, because as I told you, the main source of the Coriolis force is rotation of Earth, and where it is are towards, okay, what do you say that the Earth rotates from west to east, and the same way, and also it is blows here, right, like this, okay, towards what? Like this, because of Coriolis force. And one more thing, okay, you can write as reason is Coriolis force. And one more thing, as I told you, the center of gravity is more at equator. That's why it attracts, and this water again comes to the equator. Thus, it completes the cycle. Isn't it? I am writing, look. Okay, this is if I want to say, right? If I want to say, okay, this is if you say the equator. What it is? Equator. And what is the reason for its movement? What is the reason for its movement? Here I am talking. Can I write winds? Winds, right? Why these currents are moving? Because of winds. And now I am writing here. So what is the reason for this? Yes, the resistance force of land. Can I write like this? And why it is deflecting like this? Because of Coriolis force. Getting my point? Or rotation of earth, whatever you can say. Similarly, why it is coming back towards equator? Why? Because of center of gravity. Okay, this thing you need to know. And now just compare here. Okay, here temperature is relatively more. Okay, and here is temperature relatively more. Temperature more means, can I call it as warm? Right, and now compare here. Temperature here is relatively less and it can be called as cold. And in geography, anything we nomenclate based on its source. Okay, naming. And how we name based on its nature, source. Okay, based we name it. And now, okay, if the water is moving from here to here means what is character? What is character here? Warm. Okay, can I call it as warm current? Isn't it? And now what is the character of this? Cold, right? And we can call it as CC. CC means climate change. No, cold current. Getting my point? That from this what we can conclude, the currents are even the agents in distribution of or in distributing temperature. Warm currents increases the temperature of higher latitude, cold current decreases the temperature of lower latitude. That's it. And you can write here is, the fourth one is oceanic currents. Okay, what again factors? Okay, cold, what do we say that? Oceanic currents are the again agents in distributing oceanic temperature. ಹಾಗಿದ್ರೆ oceanic temperature ಅನ್ನ ಅಥವಾ whatever the temperature ಅನ್ನ so you decide ಮಾಡ್ತವೆ. ಆಯ್ತಾ fourth?